we see the some definition related to the AC quantities. Then we have derived the equation of AC voltage. Let's start the new topic, average value and mean value. So the average value means that a steady current when flow in any DC circuit, when DC current is flow in any circuit for a given time, it transfer the same charges as transferred by the, suppose AC current is flowing in the same circuit for the same time duration. So that value of alternating current or AC quantity, that is called as the average value. Yeah. As you can see here in the figure also, the DC source that supply the current, and this current provide the charge to this resistor. Same amount of charge is provided by this AC current or alternating current to this resistor in the same circuit for the same duration of the time. So this AC quantity is called as the average value of the AC quantity. Yeah. Now the average or mean value of alternating quantity over a given time interval is what? That is nothing but a sum of all the instantaneous value divided by the number of values taken over that intervals. Yeah. That is a mathematical equations of average value. Area under the curve for which you measure the average value, divide with the length of the base of that curve. So that gives the average value of that quantity. Clear? All of you understand this definition of average value? It is clear to all? Yes or no?
Yes, sir.
Yes.
Yes, sir.
Okay. So mathematically, how to write down this equation? So suppose if you take the average value, if you want to take the average value of any, suppose alternating quantity. Okay. So you require the integration. Suppose I want to find out the average value of the current, alternating current. So mathematically you can write down like this way. So 1 upon T, that T is nothing but a base of this curve. So generally 50 Hz frequency, the total duration of one cycle is how much? 2 pi degree. Okay. Or you can say that 20 millisecond in time. Clear? So this T is nothing but a time duration for which you measure this average value. Integration of which quantity? Here I measure the average value of current. So integration of current, I is the instantaneous value of the current. So take the integration 0 to T of I with respect to time. Clear? Because here we take the base as a time. Clear? If your base is angle, then you can take here integration with respect to angle, like d omega t. Clear? So this is the mathematical expression by which you can represent the average value of any quantity. It may be average voltage, it may be average current, it may be average power. Clear? So let's derive the equation of average value of sinusoidal alternating current. So how to derive this? So as you know that sinusoidal current, that is a symmetrical wave. Symmetrical means whatever the positive magnitude, same magnitude you get in the negative half cycle. Yeah, so it is symmetrical about this x-axis. Yeah. So this is called as a symmetrical wave. So if you consider the half wave only here, when your waveform is symmetrical only, at that time you consider the half cycle to calculate the average value of this quantity. Clear? So here we consider the only half cycle to derive the average value of this sinusoidal alternating quantity. So as we know that the value of current I is equal to what? Im sin theta. Clear? Sinusoidal or alternating quantity, that mathematically we express like I is equal to Im sin theta. If it is a voltage, then V is equal to Vm sin theta. Clear? But here we take the average value of sinusoidal alternating current. So I is the instantaneous value. So how to do this? How to find out average value? So for that we require the integration from 0 to pi. Clear? But integration of what? Integration of some instantaneous value. Clear? So suppose that at any instant d theta, the value of current I is equal to Im sin theta. So for that, as per the equation, this equation, I average is equal to 1 by T, 0 to T integration I into dt. So as per this equation, we have to take the integration to derive the equation of average value of alternating quantity. So as per the definition of average value is area under the curve. Here we find out the average value of only half cycle. So area under the half cycle divided by length of this half cycle in terms of angle or in terms of time. Here we take the length in terms of angle. Clear? Because here wave shape is represented with respect to angle. So length of the base over the half cycle, that becomes what? Pi. Clear? Because we take integration up to 0 to pi. So area under the half cycle is what? So it is nothing but integration of instantaneous value from 0 angle to pi angle. So you can see that here I am taking integration from 0 to pi of the instantaneous value I with respect to theta, and divide length of the base, that is pi, because here we take average for half cycle. So if you take the integration of this 1 upon pi, that is a constant, integration of 0 to pi, I is replaced by what? Im sin theta, because between 0 to pi the value of I is Im sin theta. It is changing with respect to angle. You can see that at 0 angle it is 0, at 90 degree it is maximum. Clear? So at different angle the value of this I is different. Clear? It is a function of angle. So replace this I by Im sin theta into d theta. Now what is the integration after this? All of you calculate this integration and give me the final answer of average value of the sinusoidal alternating current. All of you take the integration and give me the final answer. I am randomly asked to anyone, only those students give me the answer. Okay. 41 number Mohit Marwani, give me the answer. Average value of.
Yes, sir. 1 minute. I'm calculating.
Yeah, calculate. Take your time. Other student also calculate. And Mohit, give me the answer.
Sir, it's minus Im by pi.
No. Not is Im by minus Im by pi. (42) Jilsa.
Yes, sir.
Give me the answer.
Minus 2im by pi.
Minus 2im by pi?
Im.
It's minus 2im by pi or only 2im by pi?
2im by pi.
2im by pi.
Yes, it is plus 2im by pi. Okay. So answer is average value of sinusoidal alternating quantity, that is 2im by pi. Let's see here how you get this. So here we get Im sin theta d theta, integration of sin theta. It is what? Minus cos theta. Clear? So Im by pi, that is constant quantity. Integration of sin theta is minus cos theta. So 0 to pi. So cos pi is what? Minus 1. So minus plus. Minus plus again, because when you take the integration from 0 to pi, again it is subtracted from the upper level, from the minus lower level. So minus cos pi, minus plus cos 0. So it is minus 2, minus is common from here, so it is 2 Im by pi. Finally you get the answer, 2 Im by pi. If you write down numerically, it is 0.637 into Im. All of you get this answer?
Yes, sir.
Okay. Next is the average value of half wave rectifier circuit. As all of you know that the rectifier operation. So what type of waveform you get at the output of the half wave rectifier? Can anyone give me the answer? What type of waveform you get? Suppose you rectify
Square wave.
square wave. No. Suppose you use a diode based rectifier, okay. So supply is AC quantity, sine wave. So what is the output waveform? What is the waveform between 0 to pi and pi to 2 pi? All of you learn the half wave rectifier, full wave rectifier circuit. બધા ભણી ગયા છે ને બધા 12th માં. Clear?
In triangle,
No, no,
0
no,
to pi.
no.
Sir,
Positive waves.
semicircles with a gap
Yes,
in between
positive.
them.
What? Sorry.
I mean, it's a positive wave.
But positive wave is, it is the what is the shape of that wave say?
Sinusoidal.
Sir, semicircle waves with a gap
Yes.
between them.
Gap between
Yes,
them.
sir.
What is the magnitude between 0 to pi? And what is the magnitude between pi to 2 pi?
So pi to 2 pi will be 0, I think.
Yes, yes, very good. So as you see that here is the waveform of half wave rectifier. Clear? It is clear? You get this type of waveform? Yes or no? Suppose you provide the sine wave. So at the output of the half wave rectifier, you get the current like this way. You get the only half wave in one complete cycle. That's why it is called as a half wave rectifier circuit, because it not rectify the negative half cycle of your supply. Because you can see that in the output you get the zero value between pi to 2 pi. Clear? So that's why it is called as a half wave rectifier circuit. Clear? So if you want to find out the average value of this half wave rectifier circuit, how to calculate this? Can anyone give me the idea? Yes, anyone? 32 number. 32 number. (32) is present or not? Hello, 32 number. Absent है 32 में?
Yes, sir.
Okay, 33 number then. 33 number. IUC. (33 number IUC. Okay, it is absent. Okay. See, I am randomly asked the question because I know that some of the students are not mentally present. Clear? Those are come only for to take the attendance. Okay, I know that. Okay, so don't take it lightly. Yeah, now I'm in all the lecture I will ask the question randomly to anyone, and those who not give the answer, I give the absent of that student for the next 5 lecture. Clear? So 33 number is absent for next 5 lecture. 41 number, Mohit.
Yes, sir.
Yes, give me the answer. Yes.
Sir, we will find area under the curve of 0 to pi divided by length of the base from 0 to pi.
Okay. Anyone want to give the answer?
0 to pi divided by length plus area from pi to 2 by divided by length.
Okay. So here, what is the magnitude between pi to 2 pi? It is
0.
Okay, so you get the 0 value for the integration. Okay, so what is the definition of average value? That is the area under the curve. Clear? Here your waveform is what? Unsymmetrical. You can see that your waveform is unsymmetrical. Clear? So unsymmetrical means what? Whatever the positive, same magnitude not get the negative also. Clear? So that's why it is called as the unsymmetrical waveform. So when you find out the average value of unsymmetrical waveform, consider the full cycle. So here area under the full cycle, that is integration 0 to pi plus integration pi to 2 pi, divide with the length of the base. Base here we take full cycle, so it is 2 pi. Clear? So one by one take the integration. First half cycle 0 to pi of I d theta plus integration pi to 2 pi. Here because value is 0 of this current, So this second term you get the 0 and divide with the base 2 pi, which is the length of the base for the duration in which you calculate the average value. Clear? So finally you get this 1 upon 2 pi integration 0 to pi Im sine theta into d theta. Clear? Again, sine theta, that is integration is what? Minus cos theta. So what is the final answer? Yes, can anyone give the answer?
I mean by pi.
Im by pi. Yes, very good. Yes, yes.
by
So
pi.
finally you get the answer, average value of half wave rectifier circuit Im by pi. So in the exam, you can ask like this way, find out the average value of the half wave circuit. Yes. So first of all, you do the waveform. Then after, step by step, like this way, you calculate the average value of this half wave rectifier circuit. Now same way, you can ask that, find out the average value of the full wave rectifier circuit. Then how to calculate this, or what change you have to do in this equation when you find out the average value of full wave rectifier circuit? Yes, anyone can give me the answer?
Sir, it is a symmetrical, so we can consider a half cycle also and then integrate it that way.
Yes, you take the
Full wave, it would be symmetrical, so we can consider half cycle and multiply by 4.
Multiply by 4 or 2?
2, sorry, 2.
Yes, yes. So what type of waveform you get? Like this way? Well, you can see this waveform. At the output of the full wave rectifier, you get this type of waveform. Clear? Positive cycle of your supply, you get the same output. In negative half cycle of your supply, which is negative, but in the output you get the positive. Clear? So that is a pulsating type of the sine wave. So you can see that you get the waveform between 0 to pi as well as between pi to 2 pi. Clear? So here, whatever the average value of between 0 to pi, same average value you get between pi to 2 pi. Clear? So that's why you just take the integration from 0 to pi, but multiply with the 2 times. Clear? Because here we want to find out the average value of full cycle. Clear? So half cycle average value multiply by 2, so that gives the average value of full cycle. Because wave shape between 0 to pi and pi to 2 pi is same, so you get the same average value for each half cycle. Clear? Or you can also find out, like, take the integration 0 to pi, then after taking the integration pi to 2 pi. By any way you can calculate the average value. So give the answer, what is the average value for full wave rectifier current? It is very simple, just multiply with the 2. So in a half wave rectifier you get the Im by pi. So what is the value of average value for full wave rectifier circuit?
2 Im by pi.
Yes, yes. But in exam you must derive this equation. Okay, don't write directly. If you ask that, find out the average value of half wave and full wave rectifier circuit, so you derive the equation of both the circuit. Okay, half wave as well as full wave. Don't write the answer directly of any one of this circuit. Okay, so here I'm write the direct answer, 2 Im by pi. So this is for self study. The calculation, it is same like a calculation we have done in this half wave rectifier circuit, like this way. Clear? So in this calculation, you have to just change the value here. Here replace this 0 by what? I into d theta. Because in the second half also you get the current. Okay. Or otherwise you can take the integration from 0 to pi I theta and multiply with the 2. Clear? So that gives the average value of full wave circuit. Clear, all of you? Now is there any doubt in the average value of quantity, AC quantity? So I move for the next topic, RMS value. So what is called as the RMS value?
Root mean square.
Yes, full form of RMS is root mean square. So what is the exact technical definition of root mean square? Well, we can say that this alternating quantity has a root mean square value. So it is same like it is in comparison with the DC source. Clear? So the steady current or DC current, when we flow through any circuit for a given time, and that produce the same amount of heat as produced by the alternating current when it is flowed through the same circuit for the same duration of the time. So that quantity of alternating current is called as a RMS value. In average value, what is this? The DC current when we flow through the any circuit and for a given time, and that transfers the charge same as the charge transferred by the alternating quantity flowing in the same circuit for the same time. But here RMS value, DC current when flow through the circuit produce the same amount of heat as produced by the AC quantity when flow through the same time for the same circuit. That is called as the root mean square value of this alternating quantity. You can see in the diagram also both have the same circuit. Here just changes what the type of the source. Here DC source, here the AC source. So this current that produce the heat in this resistor for a particular duration, same amount of heat produced by this current into this resistor for the same duration of time. So this current is called as the root mean square value of this alternating quantity. Yeah. So this is the main difference between average value and RMS value. Remember, in average value we consider the charge, same amount of charge transferred by DC and AC. Here in RMS value we consider the same amount of heat produced by the both the source. So in that way define the RMS value of the alternating quantity. Now same like average value, here we calculate the RMS value of the sinusoidal alternating quantity. So how to calculate this RMS value? So as we know, the instantaneous value of sinusoidal current is Im sin theta, or you can represent Im sin omega t. Here there is a wave shape of sinusoidal current. So as you know, the full form of RMS, that is what? Root mean square. So if you find out the sinus RMS value of current, so it means that that is a mean square. Last two word, mean square means what? Mean of the square of this that quantity. So here mean of the current square, because here find out the RMS of current. So mean of the current square, it means average of this current. Which current? Instantaneous value of the current. So you mathematically represent like this way. So how to find out mean of this square of the current? Again by taking the integration for full cycle. So take the integration from 0 to 2 pi. What is the magnitude? Instantaneous value I, its square, so I square into d theta, divide by 2 pi, because it is a mean of I square or average of I square. So in which duration you get this I? Between 0 to 2 pi. Clear? So that's why this is called as the mean of the I square. All of you clear this? What is the meaning of mean square? Mean square means mean of the square of that quantity for which you measure the RMS value. Here we measure the RMS value of current. So taking the mean of I square. Same way if you calculate the RMS value of voltage, so take the mean of voltage square, where V is equal to what? Vm sin theta or Vm sin omega t. Clear? So same way here take the integration from 0 to 2 pi. I is Im sin theta. So here it is replaced. So Im sin theta whole square divided by 2 pi into d theta. Now after this step, simplify and give me the answer of RMS value of alternating quantity. Yes. 54 number. Give me the answer.
Yes, sir.
Other student also calculate.
Sir, Im by root 2.
Yes. The integration of this one, mean of I square. It is not Im by root 2. Here we what find out? We find out mean of I square, not RMS. Okay. Integration of this only. $55 number.
Sir, 1 minute calculating.
Im by 2.
No, no. Can anyone give me the answer? Mean of I square.
Im square by 2.
Yes, very good. Im square by 2. So in this, after this step, replace the sine square theta by what? 1 minus cos 2 theta by 2. Clear? So you can see here, I replace this sine square theta by 1 minus cos 2 theta by 2. So 1 by 2 here, 2 is common. So this becomes Im square divided by 4 pi. And then after take the integration of 1 minus cos 2 theta. So integration of 1 with respect to d theta is theta minus integration of cos 2 theta. So integration of cos 2 theta was sine 2 theta divided by 2. So you can see that sine 2 theta divided by 2. Clear? And integration is 0 to 2 pi. So take this. Now replace this theta by what? 2 pi minus 0. And same way sine 2 theta by 2, that is in which theta is replaced by 2 pi as well as 0. So if you simplify this, so finally you get the answer Im square 4 by 4 pi, 2 pi minus 0. Because when you put the 2 pi into this theta, so sine 4 pi is what? That becomes 0. And sine 0 is also becomes 0. So this term, second term is becomes 0. So only remaining is what? 2 pi minus 0. When you replace this theta by 2 pi minus 0, so you get the finally answer Im square by 2. That is the answer of mean of I square. But we want to find out what RMS value. R means what? Root of mean square. R means what? Root. Means square root of this mean of I square. So if you take the square root of this Im square by 2, so final answer is what? Im by root 2. Clear? Let's see here. RMS value of alternating quantity is what? Mean of the square. Sorry, square root of mean of the square of the instantaneous value of the current. Mean of the square we calculated Im square by 2 and square root. So finally you get the answer Im by root 2. So that's why it is called as a root mean square. First you find out mean square, then take the square root. So that gives the RMS value of that particular quantity. So RMS value of alternating quantity is 0.707 into Im. All of you clear with this? Whether Amash answer?
Yes, sir.
Yes.
Okay. Okay. Now next is find out the RMS value of half wave rectifier circuit. Find out the RMS value of half wave rectifier circuit. Same like as we calculated the average value of half wave rectifier. Same way here calculate the RMS value of half wave rectifier circuit. Okay. 34 number. How to calculate this? What is the first step? 34.
Yes, sir.
What is the first step to calculate RMS value? Yes? Give me the answer. What is the first step? $34 number. I'm asking to you.
Yes, sir. Yes, sir. 1 minute.
35 number.
Yes, sir.
Yes. What is the first step?
So, average.
No, here we not find out average. Here we find out what? RMS value. Okay. RMS value of half wave. Average value we already calculated.
Okay.
See, is the same like a previous theory here. What we do first find out the mean of the square. Okay. So mean of the current square. See here in the previous slide. Here mean of square is what? Take the integration from 0 to 2 pi. Here of the quantity instantaneous value divide with the base 2 pi. So same thing do here. Here your half wave rectifier circuit. Yes.
Instead of 2 pi.
What?
Instead of 2 pi, we will use a pi and replace 2 pi with pi in the same previous derivation. We don't need to find from pi to 2 pi. We just replace 2 pi, 2 pi.
Yes. Here to take the integration from 0 to pi, separate this integration because pi to 2 pi you get the 0 value like this way. You can see here. Mean of I square. 0 to pi you get the instantaneous value is what? I. So take the integration of I square into d theta. But between pi to 2 pi you can see you get the 0 value. Clear? So the second term becomes 0. Divide with the base. Okay. Now what is the value of this integration? Finally give the answer.
IM by 2.
No.
IM
Answer
square
of
by
mean
4.
of I square. Mean of I square.
IM square by 4.
Yes, very good. Yes, very good. IM square by 4. Answer is IM square by 4. All of you please calculate this, okay? Not give the answer directly. All of you simplify this by taking the integration. So the next step you can see that 1 by 2 pi is constant. Taking the integration of I replaced by Im sin theta. Again sin square theta is replaced by 1 minus cos 2 theta by 2. And again take the integration. So finally you get the answer Im square by 4. Clear all of you? Now we need to find out what root mean square. So root of this value is what? Square root of Im square by 4. So finally you get the answer is what? Im by 2 or 0.5 into Im. Clear all of you? So remember this equation because this equation helpful to calculate the example also. So in exam you can ask that find out the value of RMS value of half wave rectifier or full wave rectifier circuit. Okay. So in example you not need to derive all this equation. You just remember the equation. But if you ask that derive the equation at that time you derive whole equation with the figure. Okay. So you remember this equation for the example point of view. All of you write down this equation. RMS value of half wave current is 0.5 into Im. Same way if it is a voltage then V is equal to 0.5 into Vm. Clear? For any quantity the equation is remains same for the sine wave. Okay. So this equation is applicable for any parameters, maybe voltage, current or power. Clear? If it is a sine wave. Clear all of you? This one?
Yes, sir.
Okay, now same way, find out the RMS value of full wave rectifier circuit. Full wave rectifier current. 17 number. 17. Absent. 20 number. 20 number absent. 21. 39 number. 39 number.
Yes, sir.
Yes, give the answer.
Yes, sir.
RMS value of full wave rectifier current. Take your time.
So we can multiply
Yes.
in half wave only and we will find out.
Don't write directly. I again repeat this. Derive the value. Okay. What is the first step? Now take the integration from which
Sir,
point to which point? Yes.
Mean
Yes.
of I square.
Yes. So mean of I square, you get the value between 0 to pi. Yes or no? What is the waveform of full wave rectifier? We already see the waveform. Okay. You get the positive cycle. You can see this waveform. Full wave rectifier circuit. Okay.
Yes.
So you get the waveform in both the intervals 0 to pi as well as pi to 2 pi. Clear? So one by one take the integration between 0 to pi I square into d theta plus pi to 2 pi integration I square into d theta divided by 2 pi base. Clear?
Yes.
So what is your answer?
Sir, RMS IM by root 2.
Yes. I am by
Root 2.
yes. Answer is I am by root 2. Okay. All of you calculate this mathematically. I give you this for the self study. Okay. This part. But all of you write down now this equation because this equation are helpful to do in the calculation of examples. Next. Now next term that is called as a form factor. So form factor
Sir,
is.
could you go back to the last slide?
Okay, this one.
Yes,
This is a derivation of this RMS value. Okay, this I give for the self study. Clear, all of you? So next term is form factor. So form factor is nothing but RMS ratio of RMS value to the average value of alternating quantity. Clear? That we have already calculated RMS value and average value of the sinusoidal quantity. Clear? Now, as we know that what is the RMS value of alternating quantity?
I am by root 2.
Yes, I am by root 2. And what is the average value of sinusoidal quantity? Average value. So the average value. No.
I am divided by pi by 2.
No. First thing we have find out that one. Average value of sinusoidal quantity.
2 I am by pi.
2
I am by pi.
Yes. See, we calculate three average value. First, we calculate average value of sinusoidal quantity. Then we calculate average value of half wave rectifier current. Then find out the average value of full wave rectifier current. Same way, we find out the RMS value three times. First, RMS value of sinusoidal quantity, RMS value of half wave circuit, RMS value of full wave circuit. Okay. If you observe that the average value of sinusoidal current and average value of full wave rectifier circuit both are same. If you see this, yes or no? You derive the average value of sinusoidal current, that is what 2 Im by pi. Clear? Same average value of you get if calculate the average value of full wave rectifier current 2 Im by pi. Clear? Same way in RMS value also. You calculate RMS value of sinusoidal quantity. That is what Im by root 2. Clear? The same value you get for RMS value of full wave rectifier circuit. Im by root 2. Clear? So by this way you can remember this. Now, if you replace this value in this form factor, RMS value we calculated that is Im by root 2. So Im by root 2 means 0.707 into Im. Okay. And average value is 2 Im by pi. It means 0.637 into Im. So if you replace this value in this equation of form factor, so you get the form factor for a sinusoidal quantity that is 1.11. So remember this one, form factor for the sinusoidal quantity or alternating quantity that is 1.1. That is a constant. Clear? All of you write down this. Equation of form factor is equal to RMS value divided by average value. Now next term is peak factor. So the definition of peak factor is that the ratio of maximum value to RMS value of the alternating quantity. Peak factor is maximum value divided by RMS value of the alternating quantity. So suppose if you find out the peak factor of the current, so it is what? Maximum value of alternating quantity current is what? So how say?
IM.
IM, and RMS value is what?
IM by root 2. So the
Yes.
answer will be root 2.
Yes, very good. So IM by root 2, sorry, IM divided by IM by root 2. So finally answer is root 2. So it is 1.414. You can see here peak factor is 1.414. Clear? This is also a constant for alternating quantity. Write down the equation and the value of this peak factor. Ratio of maximum value divided by RMS value of alternating quantity. Clear, all of you? Is there any doubt up to this?
No, sir.
So let's start the example. Write down first, find the average value of RMS value, form factor and peak factor for half wave rectifier and full wave rectifier alternating current. Find the average value, RMS value and form factor and peak factor. We already calculated the average value and RMS value. Okay. So we already know this RMS and average value for half wave as well as full wave rectifier circuit. Now what is the form factor and peak factor? Directly calculate form factor and peak factor for half wave as well as full wave rectifier current. As you know the equation of form factor as well as peak factor, which is in terms of RMS, average and maximum value. First find out. Yes.
Form factor for half wave is pi by 2.
Form factor.
Form factor for half wave rectifier.
Yes, yes, it is pi by 2. Yes, it is pi by 2. So answer is what? 1.57. Pi is what? 3. Pi value is what? 3.414. Okay. Divide by 2, so you get the answer 1.57. Now what is the peak factor for the half wave rectifier? You get the answer 2. Clear? Peak factor is what? Maximum divided by RMS value. Maximum is IM. RMS is what? IM by 2 for the half wave rectifier. Clear? So answer is 2. Now same way calculate form factor and peak factor for the full wave rectifier circuit or full wave rectifier alternating current.
2 by pi.
Sorry?
2 into root 2 by pi.
2 into?
Root 2 by pi. Form factor.
So what is the final answer numerically?
Wait.
What is the RMS value of full wave current?
Pi upon 2 root 2.
Pi upon 2 into root 2. Yes, very good. So numerical value is what?
Just a second.
Yes. $1.11. Yes or no? So see that whatever form factor you get for the, you can see here, whatever form factor you get for the sinusoidal current, see here we derive also here, clear? In the previous slide, form factor for the alternating quantity. That is also 1.1, and form factor of the full wave rectifier is also 1.1. Clear? Why? Because RMS and average value of full wave rectifier current is same as the RMS and average value of the sinusoidal current. Clear? That's why you get the same value. Same for the peak factor also. Peak factor you get for the sinusoidal quantity or alternating quantity is what? 1.414. Clear? Here, what is the peak value for full wave? That is also Im. RMS value is what? Im by root 2. So again you get the same answer. Clear? 1.414. Clear? So you remember like this way. Full wave rectifier, form factor, peak factor, average value and RMS value all are same as the for the alternating quantity. Clear? Now clear all of you? Is there any doubt?
Yes, sir.
Okay. So let's move for the next example. Write down. Alternating EMF represented by E is equal to 200 sine 2 pi 50 t. Find maximum value, second frequency, third time period, and fourth one is angular frequency. So give me the answer one by one. 60 number. Give me the answer. Maximum value. What is the maximum value?
Sir, maximum value of EMF is asked.
Yes, yes. Because EMF is given. Also.
200.
200.
Okay. Then frequency.
50.
50. Yes. Yes. So you can compare this equation. E is equal to 200 sine 2 pi 50 into t with which equation? E is equal to EM sine 2 pi f into t or sine omega t. Clear? So frequency is 50. Yes. Time period.
0.2.
0.2.
1 by 50. 1 by 50.
But what is the time? What is 1 by 50?
0.02.
Yes, 0.02 second. Okay. You must write the unit of each and every term. Frequency in hertz. Maximum value of EMF. That is what in volt. Time in second. Now last one, angular frequency.
31.4.
What?
31.4.
31?
0.4.
No.
31.4. 31.4.
No. See, what is omega? Omega is what? 2 pi into f? Yes or no?
So 314.
314.15.
314.
Yes, answer is 314.2. What is the unit? Unit of angular frequency.
Radian per second.
Yes, very good. Radian per second. See, you already see the definition of all these terms. Okay, maximum value, frequency, period, angular frequency. Okay, so see the last lecture. So answer of all these 4 parameters given here. You can see this. Maximum value 200, frequency 50 Hz, time period 0.02 second, or you can say 20 millisecond, and angular frequency is 314.2 radian per second. Clear? All of you get this answer? So this type of question can be asked in 2 marks in exam. Now next is second example. Write down all of you. A sinusoidal voltage has a value of 100 volt at 2.5 millisecond, and it takes time of 20 millisecond to complete the 1 cycle. Find the maximum value and time to reach it for the first time after the 0. Sinusoidal voltage is given 100 volt at 2.5 millisecond. It takes time 20 millisecond to complete 1 cycle. Find the maximum value and time to reach it for the first time after the 0. It means how much time is required, this quantity, to reach the maximum value first time after the 0 instant. First of all, give me the answer of maximum value. 41 number, give me the answer. (41) number. Absent?
Yes, sir. 1 minute. Calculating.
Okay, calculate.
Sir, 5 millisecond answer of time.
First, give the answer of maximum value. Okay, 41 number. Give the answer. Yes, final answer. Time period is 5 milliseconds. Second answer.
Sir, 141 volt.
Yes, 141.4 volt. Answer of EM, maximum value. Okay, which equation you use? E is equal to EM sin theta or EM sin omega t. You can replace omega by 2 pi into F. Clear? So here what is F? Here time period is given. In one complete cycle it takes 20 milliseconds. It means frequency is what? 1 by 20 milliseconds. So it is 50 Hz frequency. Clear? Now voltage is given 100 volt when time t is 2.5 millisecond. So use the equation E is equal to EM sin 2 pi F into T. Replace all this value and find out EM. Clear? So finally you get the answer EM is equal to 141.4 volt. All of you get this answer? Is there any doubt? Yes, anyone? Is there any doubt up to this?
No, sir.
Okay, so now next is find out the time required. Find the maximum value and time to reach it for the first time after the 0. It means when this value reach the maximum value first time after the 0 instant, so that time you calculate. So use the same equation E is equal to EM sin omega t
by 2.
and put this value, maximum value 141.4 in this equation, and after that put E is equal to EM 141.4 because at that time it reached to the maximum value. Okay, so you find out this time t. So now E is replaced by EM because we find out the time at which your E becomes maximum value. Clear? So if you do this, like replace this E by EM, so EM is cancelled out, so that becomes 1 equal to sine 18,000 into t. Clear? And take this sine inverse. So sine inverse 1 is equal to what? 18,000 into t. So sine inverse 1 means what? When sine becomes 1 at 90 degree. Clear? So 90 is equal to 18,000 into t. So finally you get the answer. T is equal to 90 by 80,000. 1 by 200 means 5 millisecond. Clear? So like this way you calculate mathematically. Clear all of you? Is there any doubt? This second answer, time to reach the maximum value first after the 0. Clear all of you? Is there any doubt? So here I stop this lecture. If you are in doubt, you can ask the question.
Sir, please share this PPT.
Yes, I will share today. Today I will share. Last lecture PPT as well as today's PPT.
Okay.